Recording in progress.
Okay, so let's start the session. So can you hear me?
கண்டிப்பா.
Can someone tell me whether you can hear? Okay, so we start a new topic today, but for B2 group, last time we continued with the assignment problem, and I want to have one more session regarding the assignment problem because to do some exercises. But for today, since B1 group is also here, I will start the new topic, that is inventory management. So I have given some homework to do based on this one. So I have seen that most of you have written the assignment and submitted. So we'll see what is inventory management and why we need it. Okay, so what is inventory? That is the basic question. So if you have gone through the exercise, you may be able to tell me that what is inventory. In this topic, we are going to study what is inventory and why do we need to manage inventory and how we manage. So those are the things we are going to study here. Now, when we talk about the inventory, now people think that inventory is a kind of record, but it is not like that. So if you read this out, you will understand inventory is the amount of material the company has in stock at a specific time. It is known as the inventory. So if you have some amount of material in hand at a specific time, we refer it as inventory. In terms of money, it can be defined as a total capital investment over all the materials stocked in the company at any specific time. So you can read that slide later. In monetary terms also, inventory can be defined. Now types of inventory are given here. Raw materials in components inventory, work in process. Work in process means still not finished product, but in between the process. Then finished goods inventory, goods in transit. The transit means the items under transportation stage are also considered as inventory. Then spare parts, tool maintenance, operating supplies, office stations, etc. All these are belong to the inventory. So these are the items that can be comes under inventory. So inventory is the amount of material company has in stock at a specific time. Then types of inventory are given below. So you can, I will set these type after finishing the lecture, then you can read them. Then why do we need to manage the inventory? That is the next question. So you can read this slide first, then I will explain. Okay, now think like this. Uh, Suppose you have an organization, uh, you are selling some items to customer. take this example. You are having some organization of firm. You are selling some items to customer. Okay, the thing is that you are not producing the items by yourself. You also buy them from outside suppliers and you keep them in your stock. And when customer demand comes, you will sell the items. So that is the process. Okay, so what will happen? Suppose, for example, customer demand is 100 units, but you have items in your stock only 75 units. Then what is the problem? I'll explain the situation again. So you are selling some items to customer, but at a specific time, you have 75 items in your stock, but the customer demand is 100. Then what will happen? Now, the thing is that you don't know the customer demand in advance. You don't know customer demand. You have 75 items. But think that suddenly one customer comes and asks for 100 items. Then what will happen? Can you satisfy the customer demand?
We have a product for the customer.
Yeah, you have only 75, but customer demand is 100, so you cannot satisfy the customer demand. If you
Yes.
then what will happen? What is the customer's reaction then? What can be happen?
He will discourage it.
Yes, customer can go to a different supplier.
Yeah.
So probably customer doesn't want to buy the 75 items from you. He may go to a different supplier. Then is it a good thing for your company?
No, sir.
No, the thing is that maybe in future also he may not come to your organization again because he doesn't trust you, so he will not come again. Or he will inform other customers also that you don't have enough stock. There is no point of reaching you like that. The other customers will also discourage. So that is a bad point for you. Then you will lose some sales. You could have sold 75 items, but since there are no sufficient stock, customer will go to a different supplier. So you will lose some sales. So there will be lost sales. Now assume the other part. In your stock, you maintain about 200 items, but the customer demand is 100. Is that good?
No, sir.
Why? Why it is not good?
It could be a loss.
Can you little bit explain about why, how it can be a loss?
So we have more items to sell, but it's it's over for demand.
Yes.
Yes, we have storage. We have to maintain storages and other supportive expenses for that.
Yeah. We can think like that. Suppose you maintain 200 unit stock. That means if you buy items from outside supply, you have to pay for all 200 items. That is one thing. So you have to put your capital there. So you have to initially make some cost to buy those 200 items. That is one thing. And the second thing is that when you store the items, there are some expenses because you have to find the storage place. Uh, then you have to maintain the stock. sometimes you have to take insurance coverage for the items. There are some people to handle the items. Like that, there are a lot of costs associated with handling of these items. So we basically call the inventory holding cost or inventory carrying cost. So if you have more items in your stock, there are more costs associated with that. Now we know that if we have low amount of inventory, then also it is not good. There are some certain cost. Cost means we lose customers. When we lose a customer, that is the cost for us, because we will lose potential sales. Therefore, if our inventory level is very low, that is a cost for the organization. If the inventory level is very high also, that is a cost for the organization, because we have to bear some cost to maintain the stock. So both cases, there are high costs associated. Then the problem is we want to know what is the exact level of inventory we want to manage to reach the minimum cost. So the very low level of inventory is also not good. The high level of inventory is also not good. So we want to know what is the best level of inventory. So the decide on that best level uh, is the objective of this inventory management section. We want to know what is the best level of the inventory to manage to get the minimum inventory cost. Okay, so this slide will read, as a lot of money is engaged in the inventories along with the high carrying cost, companies cannot afford to have any money tied in the excess inventory. So that is what I explained. So if you buy 200 items, you have to pay for all 200 items, even though the demand is 100. So that is an extra cost. Then any excessive investment in inventories may provide to be a serious drag on the successful working of an organization, because you have to maintain the inventory. There are certain costs associated with maintaining the inventory. So that is also a high cost. Thus, there is a need to manage our inventories more effectively to free the excessive amount of capital engaged in the material. So we have to decide on the best level of the inventory. Okay, so good inventory management is essential to the successful operation for most organizations, because of the amount of money invested in inventory represent and the impact of the inventories have on daily operation of an organization. So I will explain that later, but you need to understand good inventory management is essential to the successful operation for an organization. Otherwise, the cost will be very high. You will understand when I explain the economic model quantity model why the cost is high. Okay, so till that, why inventories are needed? So that is the next question. Now, basically, one reason is that if you want to satisfy the customer demand on time, we want to have the inventory. So that is one thing. Inventories are needed because demand and supply cannot be met for physical and economical reasons. So there are reasons that we cannot exactly met the customer demand with supply. Therefore, we have to have some extra stock in the inventory. So that is one thing. Then, to safeguard against the uncertainties in price fluctuations, supply conditions, demand conditions, lead times, transportation contingencies, etc. So I will explain in this way. Suppose if you know that the price will be increased in the future, then it is better to have some extra items in your stock. Otherwise, you have to pay more in the future. So that is one thing, that is called the price fluctuations. To safeguard against the uncertainties in price fluctuations. So in that cases, it is beneficial to have extra items in your stock. Then supply conditions and demand conditions are there. Supply conditions and demand conditions means sometimes when you buy items from suppliers, they will put some conditions. For example, they will say if you buy 100 items, they will give some discount. But if you buy 200 items, they will give some special discount, some more discount. So in that case, you want to buy 200 items to get that discount. So those are called supply conditions. So in that case, the people naturally tend to have more items to get that financial benefit. So in those cases, we need to have some inventory, extra inventory in hand to take advantage of quantity discount, economy of scales in transportation, etc. So quantity discount I explained. The economy of scale in transportation. So what is the meaning of economy of scale in transportation? Suppose you buy 100 items and you want to transport those 100 items to your stock, your store. Then there will be a certain transportation cost. But even if you transport 200 items, the transportation cost may be the same. Now, for example, suppose you transport your 100 items by a truck, then basically there is a cost. But if you transport 200 items using the same truck, the same transportation cost will be there. So in that case, it is advantageous to transport 200 items because the transportation cost is divided among 200 items. So in that case, it is called economy of scale in transportation. If you want to get the advantages of that transportation cost, you buy 200 items. So that is called the economy of scale. Then to reduce machine idle times by providing enough in-process inventories at appropriate locations. So this is basically applied to production processes. Now, sometimes there are cases that if you produce items, that production process requires processing on more than one machine. So if you process one from one machine and give that item to the other machine, there will be a separate processing. But if you don't have enough items received from the previous machines, your second machine will be idling. So that is why you need to have extra items from the previous machine. So that is called reducing machine idle times. To reduce machine idle times by providing enough in-process inventories at appropriate locations. Then to reduce clerical costs associated with order preparation, order procurement, etc. Okay, when you place order, there are some costs associated with that placing of the order. So you have to use some stationery, then maybe clerical cost. Clerical cost means you have to pay for telephone and other charges required for that. There are associated cost with that order placing. So that is called the ordering cost. The ordering cost means the stationery charges, clerical charges, telephones, then postal charges, all things are there in the ordering stage. Therefore, suppose you place 10 orders per year, then there are certain costs. But if you place 20 orders per year, then the ordering cost is high. To reduce the ordering cost, sometimes you have to buy more items because that will reduce the number of orders per year. Therefore, to reduce this ordering cost also, sometimes it is necessary to have more inventory. So these are the basic cases that we want to have inventories. So definitely we want to have inventory, but the level of inventory is the problem. We have to decide that carefully. whether it is low inventory or high inventory. In both cases will have problems. But to decide on the optimal level of inventory, we study this topic, inventory management or basic inventory control. Okay, so these are the costs associated with inventory. So you can see that basically there are 4 cost components. Basically, there are 4 cost components. So unit cost, the procurement cost, it is also called ordering cost. Then carrying cost, or it is called holding cost also. Then stock out cost. So sum of these 4 components will give the total inventory cost. So we'll see one by one. The unit cost. Unit cost is usually the purchase price of the items under consideration. If unit cost is related with the purchase quantity, it is called as discount price. So discount price we are not going to discuss under this module. So I want you to understand what is the unit cost. Suppose you are going to buy some items at 50 rupees per unit. Then that is the unit cost. 50 is the unit cost. So if you buy 10 items, the total purchasing price will be 500 because unit cost is 50. You are going to buy 10 items, therefore the total purchasing price will be 500. So the unit cost is 50. Then the next one, ordering cost, that I explained earlier also. This includes the cost of order preparation, tender placement, cost of postages, telephone cost, receiving cost, all those things are there for the ordering cost. The ordering cost is basically the cost component which associated with placing the order. So you have to place the order from the outside supplier, then there will be certain cost. So that is called the ordering cost. So that name itself describe what is the cost there, ordering cost. So that is the second cost, unit cost, ordering cost. Then the third one, carrying cost, or we call it holding cost. Holding cost represent the cost of maintaining inventories in the plant or store. It includes the cost of insurance, security, warehouse rent, storage, then taxes, interest, spoilage, breakages, all these things are there. That comes under category holding cost. So unit cost, or we call sometime purchasing cost, then ordering cost and holding cost. Then stock out cost. Stock out cost means, as I explained earlier, if we have a loss of demand due to shortages, there will be the cost. The cost because of not losing customers, the bad impact is there for the organization, loss of customer, loss of goodwill, then maybe in some cases there are contracts agreements between the suppliers and the customer. So if the supplier cannot supply the customer demand, maybe some penalty have to be paid. Therefore, all these are associated with stock out cost. Because of you don't have enough inventory, you have to pay that penalty according to the agreement. So that is a cost for the organization. So whenever you have stock out, there will be associated cost. So those are the 4 cost components associated with the inventory. So when we take all together these 4 cost components, we will have the total inventory cost. Our objective is always to minimize the total inventory cost. Any question up to this level before we proceed further? So now come to the previous example that I mentioned. You buy some items from outside supplier and you are selling those items to customers. So this is only for example for you to understand the concept. One particular example to understand the concept of this inventory management. You assume that you buy some items from a supplier and you are selling those items to customers. Then basically you order items from the supplier. Then you have to decide how much you should order. That is one thing. Okay, so I will explain. You want to know how much to order and when to order. These two questions are very important uh, in this inventory management. So if you think of that example again, that is only for to understand this concept. You buy some items from supplier, so you are here. Okay, so you have suppliers and customers. Okay, customers. So you buy items from suppliers and also you sell them to customers. Okay, so you are buying from this supplier means that you have to order from this supplier. Okay, so you place orders. You place orders from these suppliers, then they will provide the items. Then customers place orders for you, then you are selling. So that is the process. Okay, so you want to decide how much to order at one time and what is the appropriate time to place the order. Okay? How much to order and when to order. But this is not answering to these two questions. You can order any amount, you can order at any time, but we are not interested at that point. We want to always minimize inventory cost. Inventory cost. So we want to answer these two questions to minimize the inventory cost, how much to order and when to order. So if you are not interested about this minimizing part, you can order any amount, you can order at any time. but it is not good for the organization, because if you want to get the maximum profit, you want to minimize the cost. So if you want to minimize the cost of the organization, definitely you have to minimize the inventory cost of the organization. So if you want to go for this objective, answering to these two questions are critical. How much to order at one time, and what is the best time to place that order? Okay, so these two questions can be answered uh, mathematically. In today's class, I will explain how we answers to these two questions. Okay, so any question? So you can see that here in the previous slide, I have explained four cost component: unit cost, ordering cost, holding cost, and stock out cost. Here, the total annual inventory cost is the sum of those four items: cost of items, uh, annual procurement cost means ordering cost, then the carrying cost, that is holding cost, and the stock out cost. Okay, so we formulate the equation like this: total annual inventory cost is equal to sum of these four cost components. Then before proceeding further, I want you to write down these notations quickly. Okay, now please write down these notations quickly. Now, based on this notation, we will develop some formulas to answer to these two questions. Okay, now can we quickly write down these notations?
Recording in progress.
Okay, so now in this equation, we'll see that the total annual inventory cost is equal to sum of these four cost components. Uh, we will analyze this equation under two cases. In case one, we will assume that there are no stock out. Always you will have the stock in your hand. In that case, how we can deal with this equation? So the case one I am going to consider here is that no stock out. When there are no stock out, only three cost items are there. The cost of items, that means the total purchasing cost, then ordering cost, and the holding cost. Okay, so if you have understood clearly, now the total annual demand is R. So that means throughout the year, you have to have this R in your hand in total. The cost of individual items, that means unit price, is P. Then what is the total purchasing cost? What is the total purchasing cost? The total annual demand is R. That means you have to have R items for the year. But the unit cost is P. Then that for that 1 year, how much you have to spend to purchase those items? What is the purchasing cost? 1 unit is P. The total should be R items. Then what is the cost, purchasing cost?
PR.
PR.
Yes, it should be PR. So 1 items P, but for the year you have to have R items. That means you have to buy those R items from the supplier. So that means you have to pay this amount. So that should be PR. Okay. Then this Q is the quantity ordered. That means for one order, the size is Q. Then how many orders you have to place for 1 year? We know that total is R, total demand is R. But for one order, the size is Q, capital Q. Now it's like that. Assume that your annual demand is 100. But at one time, you order only 10 items. Your annual demand is 100. At one time, you order 10 items. Then how many times you have to order for that 1 year?
10 times.
10 times. If your order size is 20, how many times you have to order?
5 times.
5 times. Now with this notation, how many orders you have to pay? How many times you have to order?
Okay.
Yes, total is R. Order size is Q. Therefore, R divided by Q. This number of times you have to order for 1 year. But for one order, the cost is C. For one order, the cost is C. Then the total ordering cost for the year should be this much. The C times number of orders. So this is the number of orders. Number of orders per year. Times the number of orders per year. Then the holding cost, to calculate this one, we want to take the average holding cost, because we cannot exactly calculate that holding cost, because if you buy some items, we don't know how long it will stay in your stock. Therefore, it is very difficult to calculate the exact holding cost, but instead we calculate the average holding cost. So it's calculated like this because I will explain this scenario in the graph. So let's say we have time here, inventory in this axis. Okay, so at the beginning, you order Q. Okay, so initially you order Q. Then what will happen? Now you have Q items in your stock. You are selling those items. When customer come to you, you have to sell these items. So when you sell these items, what will happen? This your inventory level reduce with the customer demand, and at one time it comes to the zero. At one time it comes to the zero. But in this case, we assume that there are no stock out. So what will happen? As soon as it comes to zero, you will get your next order. Next order is also size Q. Then what will happen? Again, your inventory level become Q. Then again with the customer demand, it will reduce and come to zero again. When it comes to zero, since there are no stock out, your next inventory will be with you. Again, it comes to zero. And again, with the customer demand, it declines and come to zero. Okay. Here again, you will get the next order. So this pattern will continue throughout the year. Okay, now when we calculate the average holding cost, we calculate the average holding cost in this way. So the maximum inventory we have is Q, the minimum inventory we have is zero. Therefore, we take the average. So average holding cost we calculate like this. So we have the maximum Q, the minimum zero. The maximum Q, minimum zero. So we divide by 2, we have the average, and we multiply this by the holding cost. The holding cost is given as H. Okay. So we multiply this by H. Therefore, we get Q plus 0 divided by 2 means Q divided by 2 multiplied by holding cost. Okay, so these are the three cost components. Now here only we are taking the average because we don't know when an item comes to our stock, how long it will be there exactly. It is very difficult to find it. Therefore, we'll take the average cost. Okay, so this equation is the sum of these three cost components since there are no stock outs. Now stock outs cost will be separately addressed that case, but for this basic case, no stock out, the total cost is equal to PR plus R divided by Q multiplied by C, Q divided by 2 multiplied by capital H. So these notations are given in the slide. So this is the basic equation for the this TC is denoted as total annual inventory cost, the total annual inventory cost. Okay, so there's nothing new. So these equations is there. I explained that this total annual inventory cost consists of 4 cost components. Now we have introduced some notations for these things and we have written that the equation mathematically. So that's it. Okay, so in order to explain the scenario, I use the graph. So we increase our inventory level up to Q. Then with the customer demand, it declines to 0. Again, we will have the same inventory level. So this pattern will continue throughout the period. Okay. Any question about the formation of this equation? If not, you can write down this equation. Now, based on this equation, we will try to answer to our two questions. Now, two questions are how much to order and when to order to get the total annual inventory cost minimum. Okay, so we will try to answer to those two questions based on this equation. Okay, first write down this equation, then I will explain. Based on this equation, we can find how much to order. How much to order means we want to find this Q that minimize this TC. Find Q that minimizes TC. We want to find the Q that minimizes TC. So that is called What is the meaning of this one? We need to find Q that minimizes TC. If you have actively done the assignment that I have given to you, you should be able to explain this one. What is the name that we call for this Q? We need to find Q that minimizes TC. Or in other words, this is Q star. Okay, so this is Q star in our notations. So in our notation, we have Q star is the optimal order quantity. So optimal order quantity is the order quantity that minimizes TC. From this equation, can we find the Q that minimizes the TC? Just think whether you can do this. We need to find Q that minimizes this function TC. So how you can do it? TC is equal to PR plus R divided by Q times C. Okay. Now we want to find the Q that minimizes TC. So we want to find Q which minimizes TC. Okay. Now this can be done mathematically from the mathematics that you have learned in the first semester. You can find this. So this is using the differentiation you can do. I will quickly explain, but this is not the time to explain this mathematics concept. But anyway, now this is a function. Now this P is a constant, R is a constant, this C and H all are constant. The only variable items is Q. Only variable items we have here is Q. What we can do is that to minimize this function, I can differentiate this function with respect to this variable Q. Okay. If this is differentiated with respect to Q, when PR is differentiated with respect to Q, what is the answer? Can someone tell me?
0.
So have you learned the differentiation in the first semester? Did you study the differentiation in the first semester? So I am asking because if not, I
Yes.
have to teach it now.
R divided by Q.
So batch representatives.
Yes, sir. Study.
Did you study the differentiation in first semester or at least in the second semester mathematics?
Yes, sir.
So I cannot hear you. You are telling something, but I cannot hear you.
Yes, sir.
Yes, sir.
I cannot hear you. Can you hear me?
Yes, sir.
Looks that I cannot hear anyone. So can someone tell me whether you can hear me?
Yes, sir.
Yes, sir.
Just wait a minute. I cannot hear none of you. Okay, now can you hear me?
Yes, sir.
Yes, sir.
Okay, now I can hear you. So you have studied differentiation. Now, if you differentiate this PR part from with respect to Q, what is the answer? I am asking only about this PR part.
0.
0.
0. Why it is 0? Because this is a constant. Q is the variable. When constant is differentiated, that is 0. Okay, so no problem with that part. Then what about the next part?
RC divided by Q.
When you differentiate that one, what is the answer? So that part you can write as, if you want, you can write this is equal to RC Q to the power minus 1. Is RC Q to the power minus 1. So when you apply nx n minus 1 rule here, then you can write this is minus 1 RC Q to the power minus 2. Is that correct?
Yes, sir.
Okay, so then it should be minus RC Q square. Then what is the differentiation of this part?
H divided by 2.
That should be H divided by 2. Okay. Now what is the next step? Now I want to minimize this function using the differentiation. Then what is the next step? I want to make this one equal to 0. Okay, so when you minimize or maximize function using differentiation, what you have to do is that you have to first make the first derivative 0. Okay. Then you can find the value of that variable. Then what you have to do is that you have to take the second derivative. If second derivative is negative, the function has a maximum. If second derivative is positive, the function has a minimum. So that is the theory. So I don't know whether you are familiar with that one or not, but anyway, I have to do that. Now we will make this 0. That means RC divided by Q square plus H by 2 is equal to 0. From here, I can find Q. What is the Q here? Can someone tell me what is Q from this equation?
Square root of 2RC divided by H.
Okay, square root of 2CR divided by H. Then what we have to do is we have to take the second derivative of this one. When we take the second derivative, we see that we get a positive value here, and from here we get 0 because now this is a constant. There is no Q variable here, therefore this part is 0. When we differentiate this part, we will have Q to the power minus 3. Then when we take this nx n minus 1 rule, minus and minus plus, so we'll get a positive quantity here. So for this value of Q, we get the second derivative positive. For Q is equal to this 2CR minus H. Okay, so therefore, this Q that minimizes this TC is 2CR over H. Okay, so when the Q takes this value, we always get the minimum value for this TC. Therefore, according to our notations, we denote this as Q star. And also there is a notation for this. We denote this by EOQ. EOQ is the economic order quantity. Okay, so economic order quantity is the order quantity that minimizes the total annual inventory cost. Total annual inventory cost. So we always talk about the annual inventory cost because you see that in the notations, we talk about annual demand. Then holding cost per unit per year. So we always talk about annual things. Therefore, we talk about the annual inventory cost. So the economic order quantity is the order quantity that minimizes the total annual inventory cost. So even if you do not understand this derivation procedure, if you apply this formula, then you will be able to find the economic order quantity. But this part for you understanding how we read this formula, even if you do not understand this part, if you can remember this formula, you can easily work out the problem. Okay, so this is what is the meaning of economic order quantity. So economic order quantity is the order quantity that minimizes the total annual inventory cost. So this is denoted by EOQ or Q star according to our notation. Okay, so this gives the answers to the question how much to order. How much to order to get the minimum inventory cost. The answer to this question is given by the economic order quantity. Okay, any question about this? So this is the meaning of economic order quantity. So if you are asked a question, what is the economic order quantity? You have to tell that economic order quantity is the order quantity that minimizes the total annual inventory cost. Okay, any question? If no question, you can write down this. Then we'll come to one example and see how we can apply this. Please write down this equation quickly, this one and this one. Okay, so we'll see this example. Okay, so please read it out. The Williams company purchased 8,000 units of a certain building each year at a unit cost of $10. The order cost is $10 per order and the holding cost is given. What are the economic order quantity? The minimum total annual inventory cost. So the minimum total annual inventory cost, the number of orders to place in 1 year. Okay. So according to our notation, we have now 8,000 here. What is this 8,000? According to our notation, now we have our notations. What is this 8,000? This 8,000 is the annual demand. The Williams Construction Company purchased 8,000 units of certain building accessory each year. So that is annual demand. So what is the notation for annual demand?
R.
R. Okay, so the R is 8,000. Then each year at a unit cost of $10. Okay. So what is the notation for this 10? Unit cost. What is the notation for unit cost?
P.
P is 10. Order cost is $30 per order. So that means C is 30. What is H now? Holding cost per unit per year is $3. What is H? 3. Okay. Williams construction 8,000 units, that is R. Then unit cost is 10. So P is 10. The order cost is 30. That means C is 30. And the holding cost is 3. H is 3. What are the economic order quantity? The minimum total annual inventory cost, the number of orders to place in 1 year. So we'll do first what is the economic order quantity. So that means EOQ, or according to our notation, that is Q star. This is equal to square root of 2CR over H. Okay, so that means 2, C means 8,000, 30, 2RC divided by 3. Okay, so what is it? You have to calculate and tell me. So 8,030, 10, 400. It is 400. So the economic order quantity is 400. Then the minimum total annual inventory cost. So our cost equation is like this: PR R divided by Q times C. So this is the cost equation. But when it comes to the minimum total annual inventory cost, we have a different notation, that is TC star. If you remember the notations, so this is TC star is the minimum total annual inventory cost. So that comes when we substitute Q star here. Okay? Because Q star is the quantity that gives the minimum cost. So that is the meaning of Q star. So when we have Q star here, we will get the minimum one. Okay, so we'll apply PR 8,000 into 10 plus R divided by Q star. It's 30 plus Q star divided by 2. Okay, so this is the minimum annual inventory cost. Okay, so we have 80,000 here, so 2,600, 600,200, 81,200. So that is the total cost. So that is the answer to second question. Economic order quantity, minimum annual inventory cost. So what is the number of orders per year? Number of orders, optimal number of orders per year. We can find the total demand is 8,000. The quantity should be 400. Therefore, the number of orders should be 20. So these are the answers to 3 parts. Okay, now can you find total cost when, let's say, in this 398, is 405. Can you find the total cost for these two cases? Now the answers to this question is finished from here. So this is the first part, economic order quantity. Then this is the minimum annual inventory cost. This is the number of orders per year. Now this is an additional part. Can you find total cost when Q is 398 and Q is 405? Because I want to explain something based on these two answers. Using these TC equations you can find, but the only thing is that you don't put Q star here, because this Q star is 400. These values are different from 400. So you can just use the equation. Can you quickly find and send your answer to me? Find the total cost when Q is 398, That is the first case. Then the second case when Q is 405. Do it quickly and send the answer. Okay, in the first case, it is this one. In the second case, $81,002,000.09. In the first case, it is 81,200.01. So you will see that both these values are higher than this amount, 81,200. At least by one decimal point, it is higher than this amount. That means it is only at 4,000 we'll get the minimum value. For any other value, if it is less than 400 or greater than 400, whatever the value, always it gives us a higher cost than this minimum one. The minimum one always comes only at 400. So that is the meaning of this economic order quantity. Under this Q star only, we will get the minimum total cost. For all the other values, definitely the cost will be higher than this amount, at least by one decimal point. Therefore, you have to understand that we get the minimum total inventory cost only at this economic order quantity or Q star. Okay, so we'll do one more exercise. Okay, construction firm need 8,000 items used in fire alarm system, so it's okay. The unit price is given, holding cost also given, ordering cost given. What is the total inventory cost under current ordering system? Okay, so no need this part. So I want you to answer to this question. What is the economic order quantity and the minimum annual inventory cost? Quickly do it and send the answer. In this case, again, R is 800. Then D is 10. C is 28. That is ordering cost. And the H, this time it is not directly given any value, but it is given as a percentage of the unit price. The unit price is 10 into 35%. So that is the holding cost. So we can say that is 3.5. Now in the earlier case, it is directly given. The holding cost is $3, but this time it is given as a percentage of the unit price. So in some questions, it is given like that. Now you have to find EOQ and TC star. So this will be 2CROH. That means 228 800 over 3.5. You can find the value. It should be R and you can continue with this value here. So can you find and tell me the values?
130.137.
That is EOQ, no?
Yes.
Okay, now there's a question. If we talk about number of items, basically we have to take integer values because 0.1, 0.3 decimal points are not realistic. So when it comes to 113.13, what is the value that we take? We have to round off that value because we are talking about number of items. It can be either 113 or 114. So which value we take?
130.
140.
40.
Yes, even though it is when it comes to mathematics, 113.13, we usually take 113. But the case is here that you see that if you multiply 113 by number of orders per year, you will end up with the value less than 800. Then that means you cannot satisfy the customer demand. Therefore, in that case, you have to take it as 114. The next higher value. Otherwise, there will be a shortage. But for the calculation here, you can use 113.13 and continue. So this is the way you answer to the first question. So I talk about two questions that we have to answer in basic inventory management. How much to order and when to order if we want to have the total minimum annual inventory cost. So the how much to order, that question is answered by economic order quantity. So in my assignment, I asked you to write what is economic order quantity. So economic order quantity is the order quantity that gives us minimum annual inventory cost. So the answer to that first question, the how much to order, that is given by the economic order quantity. So the next question is when to order, that is determined by the reorder level. So I will come to that one in the next class. Okay, any question up to this point before we end up the session today?
Sir, එතකොට මෙතන what is the economic order කියන එකට අපිට අපි 140 ද දෙන්නේ
114. 113 આવුත් වෙන්නේ ඔයගොල්ලෝ annual calculate කරනකොට 800ට වඩා අඩු ගාණක් එන්නේ. Then there will be a shortage.
එතකොට සර් TC එකටත් අපි එයාගේම ආදේශ කරන්න ඕනේ.
ඔය යගේම දාලා හද. Okay, any other questions?
එතකොට ඉන්වෙන්ටරි කොස්ට් එක දශම ස්ථාන වලින් තිබ්බන ප්‍රශ්නයක් නෑ නේද?
ඒක ප්‍රශ්නයක් නෑ. කොස්ට් එකක් නේ.
කොස්ට් එක.
Okay, any other questions? Okay, so no question, we'll stop the class for today. In the next class, we will discuss the answer to next question. That means when to order. So that is determined by the reorder point. After that, we can have one more class to talk about the demand forecasting. Then we can finish it. For B2 group, I will take another class to continue with the assignment problem. One more exercises. Okay, so we'll stop the class for today.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah.